Welcome viewers, in this video we will see the procedure for simplification of POS function using Karnaugh map, K-map. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive, link is given in the description box. Now we'll go to the topic. So the POS function, how to simplify the POS function using the K-map. So in practice the designer should examine both the sum of product and product of sum reduction as an which is more simplified. So we need to identify whether SOP form or POS form is simplification, simple form, so that in order to reduce the Boolean function. Once the expression is plotted on the K map, instead of making the group of ones, we have to make a group of zeros. In SOP form, we will mark the function as 1. In POS form, it is marked as 0. All the given terms are marked as 0, so we need to group the zeros, right? So in POS function everything is inverse of SOP function. SOP function will mark it as 1, here we need to mark it as 0, and we need to check to group the zeros. There we will group the ones. Each group of 0 result a sum term, and it is nothing but the prime implicant, right? Each group of 0 is a prime implicant. The technique for using map for POS reduction is simple step by step process, and it is similar to that one used in the earlier, that is SOP form, right? So first we need to plot the given terms as a zeros, and we have to make it as grouping, either 8 group or 4 group or 2 group, or finally it is 1 group. Then we can follow the same procedure what we followed in SOP form, right? So based on this summary we can go for a important points. Point number 1, plot the K map and place zeros in those cells corresponding to the zeros in the truth table or max term in the product of some expression, right? So while plotting the K map in POS form, we are placing the zeros from the truth table or product of some form, POS form. We have to mark it as zeros. In SOP form, we mark it as 1. Check the K map for adjacent zeros and encircle these zeros which are not adjacent to that any others. These are all called isolated zeros. That is, we have to make the group of 8 0 or 4 zeros or 2 zeros, or finally only 1 0. That 1 0 is called a isolated zero. Not possible to group with any other zeros are called a isolated zeros. Check for these zeros which are adjacent to only one other zero and encircle such pair, right? If possible to grouping with the 2 zeros, 4 zeros and 8 zeros, we can make a pair, right? So what are the pairs are available? Check for quad or octet. Octet means quad means 4 zeros, octet means 8 zeros, right? So if it is possible to make either 4 0 or 8 0 adjacent zeros, even if it is contains some zeros that have already been encircled, right? So already some zeros are encircled, mean even though we can try for grouping of 4 or 8 zeros. While doing this, make such that there are minimum number of groups, right? So the main thing is we have to make a minimum number of groups. So first we need to identify any 8 zeros are available. The next step, we not available mean we can go for 4 zeros. If 4 zeros also not available mean 2 zeros. Finally the single zeros, right? So that we can make the minimum number of groupings, right? We have to encircle the minimum number of groups, and also all the zeros should be covered, right? Combine any pair necessary to include any zeros that have not been yet grouped, right? After grouping these 8 zeros, 4 zeros or 2 zeros, even though after grouping this any zero is not covered, we have to cover that zeros, right? So that finally all zeros should be covered either in 8, 4 or 2 or 1, right? It should be covered. All the zeros should be covered. We need to ensure that, right? That not have been grouped. Any zero have not yet been grouped, that we need to identify. From the simplified POS expression for f by taking product of some term for all the groups. From the group we need to finalize the final expression, simplified expression. Now we'll see one example for this POS function so that we are able to understand very clearly. So in the example 1, minimize the expression using the K-map, right? The expression given is y equal to a plus b plus c bar. So this is called a product of sum. All terms are product multiplied and the terms available is sum. That is called product of sum, right? A plus b plus c bar. Next term is a plus b bar plus c bar. Third term is a bar plus b bar plus c bar. Fourth one is a plus b plus c. Fifth one is a bar plus b plus c, right? So there are 5 terms available, right? So 3 parameters are there, a, b, c. So all having a, b, c, 3 parameters, right? So we need to plot the 3 variable K map, right? So we'll consider this 3 variable a, b, c. A is available vertically, b and c is assigned horizontally, right? So a having only one term, so 2 possibilities, a bar, right? So all things are just opposite to the SOP form. In SOP form we will have a bar and a. Now we have a and a bar, right? A is taken as 0, a bar is taken as 1. Then BC, this horizontally we are assigning BC having 2 variables, so 4 possibilities, right? B plus C. In case of SOP form we will put B bar C bar, right? B bar into C bar, now it is B plus C. B bar C bar is now changed to B and C, B plus C, just opposite to that of SOP form. Then B bar plus C bar, then B bar plus C bar, B bar plus C, right? So these 2 variables are assigned for 4 different combinations, right? This is 0, 0, 0, 1, 1, 0, 1, 1, right? 0 refers normal value. Normally in SOP form 0 means complemented form, right? So this is 0, 0, 0, 1, 1, 0, then 1, 1. This third and fourth column is interchanged, right? In K-map the third and fourth column is interchanged, so that we are getting B bar plus C here, B bar plus C bar in the third column. Now we need to assign the 0 for POS form. We are marking as 0. In SOP form is 1, is 0 for the given 5 terms. First we will see A plus B plus C bar. So here the A is available. Where is B plus C bar is available? This is B plus C bar, right? So A, B plus C bar, this is the first term. The first term is marked as 0. Then A, B bar plus C bar. Here A is available. Where is B bar plus C bar? Here available, B bar plus C bar. So A, B bar plus C bar, this is the second term. This one is second term. Then A bar plus B bar plus C bar. Where is A bar? Is A bar is available. Where is B bar and C bar? This B bar and C bar. So A bar and B bar plus C bar is the third term. The third term is marked as 0. Fourth term is A plus B plus C. Here A is available. Where is B plus C is available? So A, B plus C. So this is the fourth term. This one is fourth term, right? Right. The last one is fifth term. A bar plus B plus C. Here A bar is there. Where is B plus C? B plus C is available here. This B plus C. A bar, B plus C. This is the fifth term. Now all 5 terms are marked together. Now we need to go for a grouping, right? So this is the first group. We are making as first. We cannot group these 3 cells because grouping of 3 cell is not permitted. Grouping of 8 cell, 4 cell or 2 cell or 1 cell. So we cannot group these 5, these three zeros, right? So this 0 can be grouped only to this 0. Similarly, this 0 can be only grouped with this 0. So there is no other way. These 0 should be grouped with this 0 and this 0 should be grouped with this 0, right? So this is group 1, group 2. After that this 0 is available alone. This can be grouped with this 0 or with this 0, anything. This 0 can be combined with this 0 or with this 0. So here in this I make it as these 2 group, right? We can make these 2 group also, right? So it is clear this 0 can be grouped only with this 0, says a group 1. This 0 grouped only with this 0 is a group 2. After these two group, this 0 is available isolated, available individually. So that can be grouped either with this 0 or with this 0. So I grouped with this 0, right? So we are getting the third group. Now we having 3 groups are available. Now we can go for a expression. We'll take this group, first group, right? So if the 2 group mean we need to verify these 2, first row and second row. Similarly, first column, wherever it covers. Here A is available, here A bar is available. So both got cancelled. What is available in first column? B plus C. So after grouping this, the simplified expression is this one, B plus C. This one, B plus C. Now take the second group, right? Again we need to verify this first row and second row and third column. It is available in third column. So the first row and third row, again A bar got cancelled. Only we have this third row, B bar plus C bar. This is second term, right? Now we'll refer this group. This group is, we need to verify this first row and second column and third column. This first row, what is available? A is available. In second and third column, what is available? B plus C bar, B bar plus C bar. So B bar got cancelled. Only we have C bar, right? So A plus C bar. This is the third term, right? So while simplifying, after grouping, while simplifying, we have to refer the corresponding rows and columns. If A bar mean that got cancelled. Similarly, B bar mean got cancelled. Remaining term we need to write, right? So in this video we discuss how to plot the K-map for POS function. That is completely opposite to that of SOP form. SOP form we marked as 1, here we marked as zeros. The grouping of cells are very similar to SOP form, right? Here we marked as zeros, right? So we solved one problem also, we got the simplified expression. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Thank you for listening.